Golftown is very proud to be the first North American retailer to offer PXG products in store. Today, we're at PXG headquarters in Scottsdale, Arizona to get a peek behind the curtain of a company that boldly broke onto the scene a little more than a decade ago and is doing things a little bit different. Very pleased to begin with Mike Nicolette. He is the Senior Director of Iron Development here at PXG. What sets PXG apart from everybody else?
When someone leaves here, they know they are fit absolutely perfectly for the best golf clubs on planet Earth. And our technology is different than other companies. You know, being a golf club designer, we have the best golf equipment on Earth. I'm going to leave it at that.
We're so happy and proud to be able to welcome PXG to Golftown. From your perspective, how important is that relationship with Golftown?
Well, you know, obviously with Golftown being the first retailer that PXG is going to, partner up with, I fully expect when I come and visit your facilities up in Canada that they will be just like our facilities here. The experience you get when you come to a PXG facility is second to none. And I know, with the Studio X experience that you guys are going to have at Golftown, when someone comes in there and gets fit for a club, they're going to be treated in a certain manner. And when they leave there, they can be confident that they have absolutely the best golf clubs for their particular game.
It's a bold statement that you guys make. Nobody makes golf clubs the way we do, period. And when you hear that, what does that mean to you?
Well, that statement is absolutely true, because the way our technology works and the way we make our golf clubs from the start is nobody would do this because it's so expensive to do it. Our irons are hollow body products. They're filled with a particular polymer. There's machining operations to put all the weighting in place. All of that starts to add up to the end cost, and nobody in their right mind would do that. And that's where Bob came up with the saying, nobody makes golf clubs the way we do, period. And he is absolutely right about that.
I love it. Mike, just to wrap up, if you could sum up the philosophy of PXG in a couple of sentences, how would you do that?
Well, I can do it in one sentence. You've never played like this before, period.
All right, so we've heard a little about the history of PXG. Now let's go see where the magic happens. The R&D team is hard at work in here. It might be a few loud machines, but it's pretty cool. With Will Nopka. Will is the R&D testing manager here at PXG. Will, what room are we in? It looks there's a lot of high-tech stuff in here.
Yeah, so we are in the R&D lab test area. And so this is where we do all of our testing, validation, research, and make all of our prototypes to develop our golf clubs.
Let's talk about some of the technology in here specifically. These stations, they each serve a very specific function, don't they?
They do. So right here we have our center of gravity machine. This machine measures where that center of gravity is in the golf club, and that's what creates a lot of the launch characteristics that you see when you hit a golf ball, like your spin, your launching.
And how do we measure it?
And so it's measured with this fixture. And so this fixture sits on top and it balances left and right, and you twist it back and forth to find the center of gravity on that plane that it's tilting on. Besides the center of gravity machine, there's the moment of inertia machine. And so this machine measures the club or whatever we're testing's resistance to twisting. What that translates to is how much forgiveness you're going to get from a specific club, also how much it resists the twisting top to bottom.
All right, Will, what do we have here?
So this is where we do our groove scanning, and we make a mold of the grooves, and there's a program that we use that then takes a very high-def picture that shows the exact profile of those grooves. And so this is how we develop better groove technology for more spin and more control for those shots around the green.
And the grooves have to be within conforming measurement.
And it also shows us that our grooves are in fact conforming to the USGA standards. So we're now next to one of our 5-axis CNC machines. This is where we create the very first prototypes of clubs that we're developing, and also where we make custom clubs and wedges for our tour players and our other staff.
How many prototypes will you have to go through before you find the right one?
We will go through, especially for wedges and irons, dozens and dozens of iterations to dial in the bounce, to dial in the geometry, and also to see how the internal cavity is interacting with our filler materials. When something first gets put in the machine, it starts out as this big steel block, and after a couple hours of machining, then becomes a perfectly precise milled wedge.
How long from steel block to finished wedge?
Generally, it takes anywhere from 3 to 6 hours, depending on the different geometries of the club that we're making. One of the most important steps that we have in designing golf clubs is seeing how they look and seeing the profile. And so our 3D laser printer that we're standing in front of is what helps us do that. So you can feel it. It's made of a very light nylon.
It doesn't weigh anything.
You can't hit it, but it helps us be able to see the shapes and the curvature and kind of make sure that what we see on the computer is what we're actually going to see when we get the samples. So it helps us prototype and design faster and shorten that process.
Will, that looks like fun.
It is. And so this is our swing robot, and this is one of the most important steps in our club validation process. And so here we're testing not just center hit ball speed, but also the forgiveness of the club by moving to the heel, towards the toe, and all over the face to quantify the ball speed and the performance and forgiveness that you get by some of the technologies that we incorporate into our clubs. So we're able to see on the computer screens too that simulated shot. So we have a few center hits right there. We're swinging at tour speeds for this test. If we were to complete this test, you would see a huge shot pattern showing the dispersion of this club like it'd be used on the course.
Can you set it to slice to mimic my swing?
That's one of the cool things for the robot. If we were to have you hit it on a launch monitor, 15 minutes later, we could then program the robot for that swing and see, okay, here's your perfect hit, here's that miss hit that maybe happens, a few times around.
So Will, we just saw club hitting ball. Here we have ball hitting club. Explain what this machine does.
So right next to us is our air cannon durability tester. And so we fix a club in there and a golf ball is fired at over 100 miles per hour at the center of the face. So it's one of the most important steps in validating both drivers and irons, and particularly irons, because our face is so thin and it's moving so much and interacting with that polymer behind it that we need to ensure that over the course of 1,000 hits that the golfer has it, that it's going to still be just as sturdy as it was when you won.
So Will, this machine is called the coefficient of restitution test. What does that mean?
So this machine fires a golf ball at a club head, and it measures the inbound velocity, then also measures the outbound velocity. And the ratio between those two values is the coefficient of restitution.
It's like a trampoline effect,
exactly.
Right? Okay.
And so what that tells us is how much energy is being returned to the golf ball after a collision, after an impact. And so it's especially helpful for testing irons and rapidly prototyping so we can see, okay, this material is faster than this one, this face design is faster than this one, and really quantify those fast before going into a full prototyping phase.
Fire in the hole! With Daniel Kirtley. He is a staff design engineer here at PXG. We have on the table before us the PXG Gen 7 irons. They came out toward the end of 2024 and they are a huge hit. And part of the reason why they're a huge hit is because it's the biggest leap forward in technology you guys have ever had on an iron.
Yeah, and we really are proud of all of the different technologies that we've put into this iron, and they really perform well for the customer out there. That's what we've been seeing. So why don't we go ahead and talk about all the technologies we've got going on.
Absolutely. The first thing I notice is this in the back of the iron. It's a weight. What is that for?
Right, so that weight in the middle, that's our weighting technology. Allows you during the fitting process to go up or down and see if you like a heavier club head or a lighter club head and a heavier or lighter swing weight. That's something that's very unique to us to be able to change swing weight that quickly during the fitting process, and we've seen increased performances. But what's housing that weight is what's new with the Gen 7 iron. That's a titanium bezel. Titanium is much lighter than steel. We were actually able to save around 5 grams just by replacing this housing with titanium versus having it be part of the steel body.
The other part of the tech story is the face and its relationship to what's inside of these irons.
Right, exactly. So something that we do at PXG is our hollow body products have the thinnest face in golf. We still have our HT 1770 ultra high strength miraging stainless steel face. That's been the same from Gen 6 on. But now what's new is our quantum core technology. And this polymer works with the face to not only provide great sound great feel, and just a good overall hitting experience, but it's actually supporting it and flexing during impact, returning energy to the ball.
Let's get a real-world example of this polymer in action, shall we?
Yeah, let's go do it. Yeah, so let's talk about all of the polymers that we at PXG have used throughout the years and all the lessons we learned.
Okay.
So with Gen 1 from TPE, we really learned we needed more energy return and less energy dampening. In Gen 2 and 3, we learned we needed something a little softer to stop inhibiting face flex. Gen 4, we learned we needed to be as light as possible. Gen 5 and 6 was a great material, but let's just show you what Gen 7 does. You'll see why it's our biggest leap forward in iron technology. So I'm gonna drop these two polymers just to show you how far we've come and why Gen 7 is our greatest leap forward in iron technology. So, as you saw there, this returned almost all of the energy from the drop, where this was dampening the energy. And this was part of one of the lessons that we learned along our way of developing throughout PXG's history.
The Gen 7 irons come in two types. There is the P and the XP. Daniel, what are the differences between the two and who is each for?
Yeah, definitely. So the Gen 7 XP, that's going to be a little longer blade length and a little more offset. And it's also going to offer the maximum distance for your game. So that's going to be for the customer that's really looking to add yards.
Okay, and the P?
Now the P took all of the great technologies that we used in the XP and put it in a little more compact club head. It's going to be a great blend of both that added distance and also workability.
And the great thing about these irons is you can make up a combo bag, right?
Absolutely. So if you're looking for distance maybe in your 4 and 5 and like that workability lower on in the bag, you can definitely do combo sets of both the P and the XP.
Let's talk Black Ops. And Daniel, before you can putt for dough, you've got to drive for show. It all begins with the driver.
Yes, sir. And we've got two different options in the Black Ops line for you guys. We've got our normal Black Ops model, and we've also got our Tour 1, which was developed with the help of our Tour players. And they share a lot of the similar technologies.
Yeah, the first thing you notice about these drivers is they look great. They're sleek, they're modern, but there's a lot going on under the hood here as well.
We've always used a carbon fiber crown, but new with Black Ops is we're using carbon fiber on our sole as well. That allows us to have a lot more discretionary weight and to move that weight to the perimeter, allowing us to achieve almost up to 10K MOI. You can actually achieve above 10K MOI in the Black Ops model with a little extra weight with our weights here on the perimeter.
The difference between this model and the Tour model?
So the Black Ops model is going to be a little bit bigger footprint, very confidence inspiring. The Tour 1 model is going to be a little shorter front to back here, a little more classic pear shaped. And you know, along with the technologies they share, one of the ones I really want to hit on is our AMF-based technology. So that's really the engine of our driver. It's a new technology. We're not saying exactly what material it is because it's that important to us.
Secret.
It's a secret. And it is allowing for not only faster ball speeds, but also a little bit higher launch and low spin characteristics. All of that add up to more explosive distance for you.
Yeah, and a lot more fun on the course as well. Now, some of the same technology trickles down into the woods and the hybrids as well.
Exactly. So different materials, but the same things that we've been learning from throughout in our entire wood development. We're actually able to go a little bit thinner on our face. We're using that ultra high strength HT 1770 miraging stainless steel. And a little bit thinner in the Black Ops model, allowing for high launch, low spin launch conditions.
Daniel, if I were to say to you the following sentence, all of PXG's great iron technology in a single package, what would you say to that?
I think that would have to be Black Ops.
Ah, what a coincidence. I just so happen to have a Black Ops 7 iron here, and this is very near and dear to you because you designed the Black Ops iron.
I did, yeah.
And tell me about them.
Yeah, they got all of PXG's great iron technology that we've used in all of our lines and throughout the years, and we finally packaged it into a game improvement iron.
How does the technology work in the Black Ops?
Yeah, so like I said, we've got our ultra high strength HT 1770 miraging steel face at the thinnest face in golf. We've got our X-Core 2 polymer technology. We've got a carbon fiber weight savings insert on the back, And when I say game improvement iron, what am I talking about? I'm talking about a little bit wider sole, a little bit more offset, and it's really just aiming to launch the ball higher, launch the ball with more ball speed, and just make the game more enjoyable.
That's the key, right? Daniel, we've talked a lot about clubs. Now let's talk about the one piece of equipment you use on every shot. It's the golf ball. Recently, PXG jumped into a very competitive ball market. You have two offerings here. Tell us about each.
Right, so we've got the Extreme Tour and the Extreme Tour X. Both utilize very similar technologies. They both have extremely fast expanded cores, and they both will have thinner, more durable urethane covers as well. And they also feature a nice little alignment line here. Our customers really like how this is able to help them with alignment out on the greens.
Yeah, anything to help you get the ball in the hole a little faster, it works for me. It's the one piece of equipment that's used on every shot. What do you suggest people do?
Yeah, so they're kind of positioned at different customers, and you can read that on the box. The Extreme Tour X is a little higher compression, higher launch, and a little higher spin. The Extreme Tour is more penetrating launch, lower compression, and lower spin. But they're both great balls, and what you should really do is go to Golf Town yourself, try them out, and see which one works best for your game.
Say hi to Grace Wilson. Grace is a staff R&D engineer here at PXG, and we're talking about the brand new Allen putter. Grace, this putter is getting a lot of attention out there. It's PXG's entry into the zero torque balance putter segment. What is zero torque balance, and how will it help me make more putts?
So if you're a golfer that struggles with the traditional heel shafted putters, this is an alternative that we've come out with here at PXG, and it is zero torque balance, which means if you hold the putter at its balance point, it's going to balance with the face pointing straight towards the target. So no matter how you twist it, it's always going to find home. And we achieve that by having the center of gravity of the putter head located directly beneath the shaft axis.
So I'm looking at the shape of the hosel here. It's very different. Why not just have a center shafted hosel?
Absolutely. So we wanted to make sure that we're maintaining a traditional mallet putter head as well as maintaining a full alignment aid here. So if you have a shaft that runs directly through the center of the club head, then that can obstruct any sort of alignment aid. And here we get this nice long line on the top face of the putter. So here we have our zero torque spotter, which is a demonstration tool that I developed here at PXG. What it is a bearing system with a clamp here that shows a very low friction grip technology. So this is a traditional plumber's neck putter here. When you take it back with our zero torque spotter, you see that the face swings open and there's no stability when it comes to face position through the putter stroke. Here we have our new Allen putter on the same device. So as you can see here, when we take the Allen putter and the zero torque spotter, obviously the face stays square, making putting so much easier for the golfer because they do not have to oppose any forces of the putter head, and the putter does all the work for you.